Deep in the Costa Rican rainforest, researchers are studying the effects of greenhouse gases on the environment. Biologists and scientists are interested in developing a better understanding of carbon transfer between the atmosphere and the forest. This data is crucial to better comprehend the long-term impact of greenhouse gases on the environment. La Selva Biological Station, operated by the Organization of Tropical Studies, located in Costa Rica, is ideally suited for this research because of the rich biodiversity present in the region.
Our mission is research, education, and the responsible use of natural resources in the tropics.
However, accurately measuring carbon transfer in the rainforest is difficult because of the lack of distributed measurements and defined models. One of the challenges with developing a model to predict the transfers and absorption of CO2 is referred to as the gap theory, which suggests that CO2 from the forest floor escapes through small, open areas in the canopy.
We're here in La Selva right now to study this theory by deploying compact trio-based wireless sensor nodes and measuring carbon emission from the forest. And the reason why gap theory is important is, of course, first of all, a scientific reason. Scientists want to know if that theory holds or not and when it does. And the other reason is a more practical one, a financial one. With the carbon credit exchange, people will want to know if what they're buying is actually a carbon source or a carbon sink.
Engineers and software people and technologically savvy biologists got together and developed this plan to put a series of towers out in the old-growth forest and then put sensors on these towers and create an infrastructure of intercommunicating towers with sensors moving on cables robotically. It's a very sci-fi vision of data collection in the forest.
To help meet the challenge of uniformly measuring carbon output, the Center for Embedded Sensing, or CENS, at UCLA used NI-Compact Rio hardware to develop a distributed wireless sensor system called SensorKit, capable of collecting environmental measurement data, including CO2, humidity, weather conditions, heat transfer, and solar radiation.
We wanted an off-the-shelf component. Compact Rio was exactly that thing. It's flexible enough so that we can connect all sorts of sensors, and it doesn't require any sort of investment in hardware, so all we need to do is write down the software in LabVIEW and get our application running.
In addition to Compact Rio, researchers selected LabVIEW for advanced analysis and a graphical interface.
LabVIEW is fairly easy to use by engineers, and we did not want to start reinventing in terms of software because we went down that path before, and it actually is a long cycle. And also, the software is intended to be used by non-experts. So we wanted something that can be used by biologists, and it's much easier for biologists to use the LabVIEW GUI than to use anything else.
System designers at CENS selected standard Wi-Fi connectivity to connect distributed measurement sensor kits. These sensor kits connect wireless measurements from researchers to measurement databases on site.
There will be nodes on the ground, and there will also be nodes suspended by cables in a robotic structure. So the jungle is lacking in telecommunications infrastructure, so even though it is possible to get power there, communications are not always possible, especially if you're going to go up in the forest canopy on a tower or even in between trees. Wireless is actually mandatory.
Using the graphical system design approach, the team was able to incorporate standard wireless communication capabilities and then share this data with researchers around the world who can apply advanced analysis tools to derive models from the data. All of the acquired data will be available across the internet through the capabilities of LabVIEW. This allows researchers to perform their own analysis using real data instead of derived models.
We are actually planning to have Google Earth GPS locations on every of the nodes that we deploy. The software already supports that, so we will actually be exporting the live data, and you can actually click on a location in Google Earth and zoom in, and you will see your data stream coming right back. The goal for La Selva and the deployment, besides verifying the gap theory, is to actually give the opportunity for scientists, for researchers and biologists around the world to get access to this data through the web without actually physically have to come here at La Selva.
With this research, scientists will gain a better understanding of the impact carbon absorption has on rainforests. This knowledge could lead to a better understanding of global warming and the impact it has on the environment.
We really need the collaboration among the engineers, the software people, the scientists. The biologists can't do all this by themselves, and the engineers can't do all of this by themselves. And so we need a really synergistic, active collaboration among people from all of these different areas to really make this, to realize the true potential that is here with this structure.